In this video, we're going to see an example from a CDF based on the Filename extension filtering. It's from the TryHackMe Strong Pass Challenge. You can find it online as well, or in the course materials. The Strong Pass Challenge, if you download it in or grab it from the source materials and take a look at the source code, and then install it in your web server. It's not a very complicated application. It's a basic login. When you log in, you have logout and change password. The change password gets your old password and then asks for a new password. Pretty much this is the only functionality that this application has, so if there's a vulnerability, it should be here. You can see the files here. There's the sign up, the login, the user, the logout file, and a bunch of the DB file, and then a bunch of normal file. So because we believe that the PHP is the vulnerable file, we're going to take a look inside of it. You see that it's a basic form that gets the old pass and the new pass and sends it to the function change pass. And if the result is false, there's an error, and otherwise it's a successful. So we gotta find the change pass file function, which is in the user.php file. See here that this is the function. It's a little suspicious because it's a little long code, and it's not a normal change password like a normal application. It seems to have some fishy things, and then it changes the password. The particular thing that we want to notice here is the .pss file, which is in the history folder and is based on the username of the user. So the file name is the username, and then puts that .pss there. So what we want to do is that we want to get rid of that .pss, because the .pss file is not executable. We want to get like a .php or something like that. So if you take a look at here, the way it makes sure that the file name is valid, it's a substr function, and we've seen that in SQL injection before. It just gets two indexes and cuts a string from that beginning index to that length. So it only cuts 255 characters from the username. So if you have a 255 character username, the extra 4 characters will be cut out of the string, so that we can create any file that we want. So that's how we bypass this. That's the initial step of the exploit, and the rest of it is creating a brute force hash that creates a reverse shell for us. Because we're not into the brute force attacks yet, we're not going to bypass that section. We're just going to bypass the file name filtering section, just to see that this works or not. Alright, let's see the exploit. The exploit.php is the exploit for that. This is the payload that runs the flag. It's in the config file, which gives us the flag. It's the CDF challenge. We want to run this as the challenge. So as you can see, this is a simple PHP code. It's nothing complicated. It's a PHP code in there, but every line is only 2 characters long, for the reasons that are related to brute forcing stuff. So once it creates a payload and creates a bunch of passwords, this is the payload. The code before has been executed once, and the payload is generated. It takes a few minutes, so now I've put that here. And now we want to change the password multiple times so that we're able to do that. So if you take a look at here, the username is y 255 times minus 4, because we want to add .php at the end. So that's the username we're going to use to sign up to the system, and the initial password is 111 because that's not important. And now the way we do this is we sign up automatically using this exploit script and keep changing the password based on the list of passwords that we had up there. and then eventually creates a reverse shell into the file. So let's run that now. You see that it created a file. This is the file that it created, and you should get the flag in there. So now let's copy that, paste it here, and it should give you the flag. So it says there's no table flag because we didn't create that, but we were able to create a reverse shell and run whatever we want in there. Now let's change the password of the sample user that we had here, for example. And you see that it's changed successfully. You can see that in the history folder we got the admin1.pss file, which should contain the changed password. But the file name filtering bypassed that .pss thing and allowed us to create a .php file. I strongly encourage you to try to do that challenge yourself from scratch and create the exploit so that you master this section.